So as promised, here is an observation where I leveled my gear to the water and measured a drop. If you have any questions, feel free to hit me up in the comments. Until then, you take care and have yourself a great day. This is the target that I made for my Lake Pleasant curvature test. Now the idea is to measure from the nail that I'll set just below the water surface to this point right here. Now, whatever I measure to this point here is what I'll set the center of the instrument at the other end. So I'll measure from that nail to the center of the instrument and make sure that these two heights are the same. Now, if the earth is flat, my crosshair should bisect somewhere here. But if the earth is curved, I made a prediction that my crosshairs will hit up here. And so that's roughly 7 inches. You got a little bit of refraction, so I had to consider that. So there's my nail. I got him set just below the water surface there. And here's my big target that we're going to be able to see from that end over there. So let's head to the other side and get set up. And here is my height above the nail. 492 to the center of the eyepiece. I don't expect you to understand what those angles mean, so I'll draw it out for you so that you'll have a better idea of what's actually happening here. So this is out at Lake Pleasant. I'm not really sure of the date, I'll have to look. This was my second visit to that location. And so here's that target that I had made. And so the idea is to set a nail down here, that way you can pull a tape measure from that nail to this black line right here. And that was a 492. And so at the other side of the lake, you want to set this instrument and measure from that nail, which represents the surface of the water, to the center of the instrument. You want that measurement to be 492. You want these two heights to match. And so if the earth is flat, then when I take and set this instrument up, I should read 90 degrees and hit this line right here. But if the earth is curved or this is dropping down, then I'll hit this mark up here. And so I ended up matching my prediction, whether you call that luck or just understanding the globe really, really well. So let's go over this. So here's my triangle. So this is the surface of the earth right here. This is the tangent plane right here. The earth over 1 mile would drop down 8 inches. But because refraction lifts this up just a little bit, you're not going to get that 8 inches. You've got atmospheric conditions. I'm okay with admitting that because it's measurable. So what do we have going on here? Well, I had to take and point my instrument, the telescope, down at this line. When I did that, I had an angle of 22.1 arc seconds, or 90:00:22.1. It's a depression angle, right? So I want to solve for, what this side of the triangle is, or this side of the triangle is right here in feet. So you set it up like this. I would take the tangent of that angle in degrees, and it would be equal to the opposite side of the triangle over the adjacent side of the triangle. The adjacent side of the triangle is the distance. The opposite side of the triangle is this guy here, that departure that we're trying to measure. So in order to get x by itself, I just simply multiply both sides by 5528. So I take the tangent of that, multiply by 5528, and I get a departure from the tangent plane, or eye level in this case, of 0.592 feet, which is approximately 7 1/8 of an inch. So if the earth were flat, there should be no drop measured whatsoever, especially if these two things are at the same height. So I really, really do appreciate that advice on taking measurements over water. I think that what you should do in this situation is actually live by your own advice and do these same measurements over water, and then we could actually have a pretty decent conversation.